Hello everyone, welcome to my channel ACT, Anita's communication tutorial. In this video, I'll discuss about pressure sensors. Here we will cover pressure, its definition and units, pressure measuring instruments like for low pressure manometers and for high pressures pressure gauges, types of pressure sensors and its applications. Pressure is a physical quantity which can be defined as force per unit area when the applied force is perpendicular to the surface of an object. It can be calculated as force per unit area. The measurement of pressure is generally associated with fluids like liquid or gases. The SI unit of pressure is Pascal or Newton per meter square, and few other units are atmosphere, bar, pound per square inch. The standard atmospheric pressure has a value of 101.3 kilopascal and 760 mm of mercury. Any physical parameter can be measured either directly or indirectly. Indirectly, we can measure by using sensors or transducers. So here it is given few pressure measuring instruments. Like for low pressures, we can use manometers. Manometers are of two types, simple and differential. For high pressure, we can use pressure gauges like Bourdon tube, diaphragm, piston, and bellows. Manometer is of two types, simple manometer and differential manometer. Simple manometer consists of fluid-filled glass tube whose one end is connected to a point where pressure is to be measured and the other end remains open to atmosphere. Whenever a gas pressure is applied, it causes the fluid height to shift proportionately. Differential manometer is used to measure difference in pressure between 2 points. It consists of a U-tube containing heavy liquid and the two ends of the tube are connected to 2 points to determine differential pressure. The next is mechanical gauges. For high pressure, manometers become bulky. Therefore, we use mechanical gauges for measuring medium and high pressures. They employ different types of mechanical elastic elements such as bellows, diaphragms, Bourdon tubes, etc. to measure pressure. The elastic deformation of these elements are used to show the effect of pressure. The pressure sensors either convert the pressure into mechanical movement or into an electrical output. The mechanical gauges not only senses the pressure but also indicate them on a dial or a scale. The mechanical movement is produced with the following elements. First, spring and piston. Second, Bourdon tube. Third, bellows and capsules. And fourth, diaphragm. Next is piston type. It is a shockproof gauge. They are mostly used in hydraulics where it has the ability to withstand shock and vibrations and sudden pressure changes. Here the pressure acts directly on the piston and compresses the spring. The position of the piston is directly related to the pressure. A window in the outer case allows the pressure to be indicated. The piston movement may be connected to a secondary device to convert its movement into an electrical signal. The next is a Bourdon tube. It is a hollow tube with an elliptical cross section. When a pressure difference exists between the inside and outside, the tube tends to straighten out and the end moves. The socket and screw helps to fix the Bourdon tube in its position, and the socket has a small capillary tube through which we can give pressure input to the pressure gauge. The tube is welded to a socket so that fluid can enter into the tube through this socket. This tube is free at one end and is properly sealed. This free end causes expansion and contraction of the Bourdon tube. The Bourdon tube has an oval-shaped cross-section and the sector is connected at the end of the Bourdon tube through an adjustable link. The gear sector is meshed with a pinion and on this seam shaft, a needle is mounted. So if the pinion rotates, the pointer also rotates and shows the reading on the dial. The spring gets compressed when the tube has pressure inside it, and it helps to bring the needle at its initial position. When pressure is released from the tube, this stopper helps to stop the needle at zero. The next is capsules and bellows. A bellow is made up of several capsules. The capsule consists of two circular shaped convoluted membranes, usually made up of stainless steel, sealed around the circumference. The membrane is attached at one end to the source and the other end to an indicating device or instrument. The bellows element can provide a long range of motion in the direction of arrow when pressure is applied. Bellows and capsules are used in many instruments and are useful for measuring small pressures. When pressurized, the bellow expand and produce mechanical movement. The next is diaphragm. Many pressure sensors depend on the deflection of a diaphragm for measurement. Diaphragm is a flexible disc which can be either flat or with a concentric corrugulations and is made from sheet metal with high tolerance dimensions. They are similar in principle to the capsule, but the diaphragm is usually very thin and is made up of rubber. It expands when very small pressure is applied. This movement is transmitted to the pointer on a dial through a fine mechanical linkage. Next is the types of pressure sensors. There are different types of pressure sensors. First, potentiometric pressure sensors, inductive pressure sensors, capacitive pressure sensors, piezoelectric pressure sensors, strain gauge pressure sensors, and variable reluctance pressure sensors. Besides this, there are other types of pressure sensors like optoelectric pressure sensors, MEMS pressure sensors, and mercury pressure sensors. Details of these pressure sensors will be provided in the next video. Next is application of pressure sensors. Pressure sensors are used for controlling and monitoring of thousands of different applications. They can also be used indirectly to measure other variables like fluid or gas flow, speed, water level, and altitude. Besides this, they are also used in food processing industries where high pressures are used to destroy many pathogens. Also, they are used in pharmaceutical industries to monitor and maintain the pressure inside the drug manufacturing chambers to protect them from germs. They are also used in monitoring gas pressure in petroleum industry and to monitor the tire pressure in vehicles and also pressure recording in combustion chamber of an engine.